Good morning, good afternoon, and good evening, and welcome to the Friday Talk Show with your host Rajiv Kulkarni on Global Electronics platform. So today's date is March 27th, 2026. 3 months of this year is almost getting over. We are heading on to the April month next week. So as you know, Global Electronics, this Friday talk show is mainly meant for electronics community, talking about all the things that are happening in the electronics manufacturing sector. It is not limited to, how do I say, just only the manufacturing, but everything evolving the manufacturing, whether it can be quality, whether it can be standards, whether it can be designing, whether it can be the market segment, and so on and so forth. The electronics market segment is growing exponentially globally, and we definitely would like to address that, considering how the electronics manufacturing, the technology trend is moving towards what and when. As you all know that these days data center, AI enabled data center, and so on and so forth are becoming more and more trending and buzzwords. And not only that, it is also becoming a big fact in the electronics manufacturing sector and contributing more to the electronics manufacturing sector from the technology perspective. So today's topic is very interesting topic because every design engineer definitely would like to experience this, would like to definitely have this kind of, the knowledge, I would say, and that is the guidelines, recommendation, and standards for a PCB design. Yes, without the PCB design, nothing is possible. Electronics manufacturing is very, very far without the PCB design. And to discuss that, we have the technology expert, the guru of design in the PCB sector only, I will say, Mr. Amba Prasad, who is based out in Silicon Valley of India, which is Bengaluru. And so he will be presenting us certain of his and sharing his knowledge of expertise in the PCB design. Welcome to the show, Mr. Ambaprasad, and good evening to you. How are you this evening?
Yeah, good. And you rightly said so. You told electronics is not possible without design. And I should go pedal one level backwards and say PCB design itself is not possible without guidelines, recommendation, and standards. I mean, that's our title.
Absolutely.
Yeah.
Yes. So let's start that, and I will start sharing a screen, and we'll start presenting the slides. Can you see my screen right now?
I can see your screen. I'm seeing two screens.
Yes.
Now one screen. Go to
Now
full screen.
Yes, here we are. Okay, let's start our today's session, and here we go to the next page. Yes,
Go
sir.
to previous page.
Mr.
Previous page.
Yep.
Guidelines, recommendations, and standards in PCB designs, similarities and the differences. Okay, today's session I am projecting only similarities, and maybe later we can go for the differences. They are same and they are different. There is a lot of confusion between guidelines and recommendations and standards. They cannot be used interchangeably. So that's how I have structured this. Go to next slide, please. Yeah, here I am showing a package technology roadmap. On the y-axis, I am showing the interconnected density per square. Some people talk in inches, some people talk in micrometer square. And then from 2005 onwards, how we progressed till 25, 26, we are there. And again, up to 2035, this roadmap is available. If we go back, 1960 is when this through-hole technology started. And again, 1984, is, of course, surface mount technology, which we are 44 years old now. And again, the projection roadmap consortium started in 1996. So three organizations, or three set of organizations, which is 60 plus years. One is 45 plus years. Other one is 30 plus years. So every 15 years, we saw some shift. Okay. Right now, we are here. And by 2025, we are looking at about, uh, if you look at the BGAs, a 1 millimeter pitch BGA is the benchmark at a PCB level. Up to 0.8 mm pitch BGA bumps, we can do. After 0.8, then comes 0.65. You have to go for a blind and buried wire through laser. So that's how even not only design, even PCB fabrication and testing, everything is a challenge. So after 0.65 millimeter, it is 0.5 and then 0.4. After 0.4, it is almost becomes like a semiconductor sort of a thing. Then we have to go for a heterogeneous integration. So this is how the industry is moving, and all these are falling in place because people are following guidelines, people are following recommendations, and even to a certain extent, standards are available. Go to next slide, please. Again, I told somewhere in late 2000, we started heterogeneous integration because the Moore's law was not giving a much desired effect. People told the slowing down of Moore's law, or it became a Moore plus or something. Every different industries called by different names. And now the package style, if you go, you see on the horizontal size of package on package, uh, high bandwidth memory. Then we see chiplets, which is very latest. And then again, it is going on and on and on. It is almost a 3D interconnects. So number of connections per millimeter square they are showing. 10,000, 10 to the power of 6 connections. It becomes 10 to the power of 7 little later, 10 to the power of 8. It keeps on increasing. Then again, if you look at the bump pitch, it started at 1 millimeter. It is on the pink line at the bottom. It became 400 microns, then 100 microns, 40 microns, 20 microns. And when it hits 10 microns and it goes up to 1 micron, it is only 3D interconnect is possible. So 3D interconnect at package level, and at the PCB level, it can be even a 0.8 mm pitch BGA at the BGA fan-out level. But at this rate, the semiconductor type of disciplines are coming into PCB design, especially on the redistribution layer. And some of the PCB design technologies like DFM, DFT and all, they are mature enough. They are getting into this packaging design. So this is where we are. Go to next slide, please. This is just a schematic. This is not a real live package. This is how a package might look like. People are showing. At the top, we are having a micro BGA. You do fan out. You may put the components inside. And again, there will be power supply also embedded inside. Then at the bottom, as usual, we have a PCB. On the PCB, it sits. So at the very top, we have the silicon. At the very bottom, we have the BGA. And even power supply is built in between. And also, if you see on the right side, there is an optical connectivity. A fiber is going out. So everything is heterogeneous integration. RF, optics, and a regular silicon can be fitted into one component. So this is heterogeneous integration. Next. Now, coming to similarities. Similarities across guidelines, recommendations, and standards. Guidelines means the device manufacturer will give you how to do it based on their simulation. They say you follow these guidelines and your layout is sure to work. Recommendations, a group of manufacturers come together. They may also have PCB fabricators and assemblers in the consortium, and they come with recommendations. When we go to recommendations, even we use a different chip or a different PCB vendor or a different assembler, it is very easy to portable. The interoperability is guaranteed. Then, of course, the standards, it sits above all this. Signal integrity, control impedance routing, all three emphasize consistent impedance for a differential pair for critical nets. Minimizing crosstalk, this is very much needed. Recommendations and standards alike require spacing rules. Then guidelines will tell you how to put the layout. So because we are mixing analog versus in one package. Then they all agree on a transmission line behavior. They all recognize that high speed traces behave more like a transmission line, requiring termination and a careful via usage. And even companies will share, they simulate the package and share the results, which can be imported into our constraints map. Go to next slide, please. Again, to send a signal for a distance, we have to spend some power. So power integrity becomes very much important of capacitors close to IC pins, which is advised. Ground and power plant design standards are available. They require a continuous plane. In fact, when we do simulation, we think ground is 0 and power is perfect 5 volts or 3 volts or 1 volt, which is not the case. There is going to be a ground bounce or a power collapse. So in a real life, so they give you the margins. And reliability and manufacturability, and design for manufacturability matrices. All framework stress manufacturable trace width, via structures and stackups. Thermal management. When the device or a PCB gets heated, your impedance may change or even a power behavior may change. So there is a power aware power integrity simulation is available. That's what we have to run. I think we can take a break now. Next, we are getting into the real standard part of this argument.
Okay, great, Mr. Amba Prasad, for presenting so many beautiful slides explaining about the guidelines and the standards and also the recommendation. It's a partial presentation as of now, but we will come back after this very quick short break. Good morning, good afternoon, and good evening, and welcome back to the Friday Talk Show with your host Rajiv Kulkarni. Every Friday, we bring in different topics on electronics manufacturing, and today's topic is the recommendation, the guidelines, and the standards that goes for PCB design. And without the PCB design, definitely there is no electronics at all. So let's continue our discussion after this small break, and I'm going to share the screen with Mr. Amba Prasad, who is our esteemed, experienced veteran in the electronics, in the PCB design itself, who is based out in Silicon Valley of India, that is Bangalore, which is a big city in the state of Karnataka, situated in the southern part of India. So let me share the screen again here so that we can continue our discussion further on this. Yes, sir. The stage is all yours, Mr. Ambaprasad.
You have to share the screen, go to the next page.
Yeah.
Power integrity is done. Now we are going to EMI AMC.
Yes.
So far we are discussing the similarities between guidelines, recommendations, where they agree with each other. But maybe next session we are going to show where they disagree with each other. Right now they're all agree. They are in sync. Any change in impedance line behavior or even a power supply behavior will manifest as EMC in the design. It manifests as EMI. To control EMI, you have to bring in EMC practices. Many designers often confuse between signal integrity, power integrity, and EMI. These three are interrelated, but these three are totally different. You try to fix one, it will affect the other. It's like fixing a leaky pipe. You try to hold somewhere, water will ooze out. So it's a very tricky, but of course, this is very tricky. But there are some good practices, thumb rules, industry experts are there. Let's go. Now, shielding and return path. All guidelines agree with each other. Guidelines recommend short return paths. Standards like military and IEC, they also give some figures. They tell you so many dBs of EMI and all. Let me tell you, IEC is mother of all standards. It is a 100-year-old company. I was telling about a 60-year, 45-year, and 30-year, but IEC is almost 100. When IEC recognizes a recommendation or a standard, that becomes a global standard. So otherwise, they are all regional and local or company standards. So IEC recommends. Then differential signaling, almost everybody agree we have to use, and they have their own protocols. Then documentation and traceability. Everything has to be documented. We cannot leave for a guesswork. And traceability. If assembly fails, they tell fabrication is bad. Fabrication fails, they say assembly is bad and design is bad, and everything falls back on the design. So we should really know what is bad. And sometimes people go up to component level, solder level, PCB material level. They go back up to that. Sometimes they recommend which copper to use. They are going to tell use a copper from so and so company. They tell that. These are the issues. Then class level. I say class level. This is not class. Class 1, 2, 3 is different. Class level. Class level is a mechanical class, electrical class, optical class, and sort of a qualification class, a performance class. So these are the classes. A class level requirements. Standards demand audit-ready documentation. Recommendations and guidelines encourage a checklist and design notes. Review process, all three will agree. We emphasize on a peer review, and sometimes even you want to get it reviewed by a reviewing agency. And then you get the validation, you get the testing, you get testability reports, everything. And you freeze your design before fabrication. Next slide, please. Here I have given a table which shows the similarities between across guidelines, recommendation, and standards. On the y-axis, I shown what is the aspect. On the x-axis, I show how they are different or how they are similar. For a guideline, the component vendor is the source. But the recommendation can be a consortium. A few vendors may come together. They may, for example, you buy a connector from a company A or company B, they fit in and they perform the same. Even the buffers, memory module, power supplies like that, they go to consortium level and they give industry best practices. Standards are available. Standard bodies are there. Authority, for a guideline, it is only authority.
Your voice is fluctuating. Just make sure that your voice is loud and clear. Yeah.
Okay. Authority comes from component vendor. It is a vendor specific. Recommendation, it is a consensus, more than one vendor or three vendors. And the standards, of course, it is a formal and it is enforceable. Then when you go to the focus, it is only layout tips. It can be a design practices or it can be complement auditable some sort of a matrices. Signal integrity, routing rules, via placement, again crosstalk minimization, impedance control numbers, and mandated impedance ranges in standards. Reliability, suggested thermal strategies, it is only suggested. But in recommendation, it is proven. They do simulation and they give you the actual figure. Sometimes they share the design also and layout, which can be imported. And the standards, they tell how to test it. Documentation, it can be application notes. It can be a recommended checklist. Or and again, it's a compliance matrices. Enforceability, guidelines are still optional. Some companies will not follow guidelines. They have internal guidelines. They take a risk and they otherwise, if it comes from a consortium, it is strongly recommended to follow them. And then standards, mandatory. If we violate a standard, we cannot get our product validated. Next slide, please. Risk and trade-off. Guidelines alone may give you some misenforceable compliance requirements, risking the audit failure. Just because I follow only guidelines, which is easy to do, I can download from Google or something and I can get it free. Guidelines are free of cost. Then if I say I'm following only guidelines, I cannot sell my product. Recommendations will take me one step closer towards sort of approval. Recommendations provide strong practices but lack legal weight. But standards, if we meet the standards, I can sell the product anywhere in the world. Standards ensure reliability can be rigid, sometimes limiting design innovation. Again, if you read the last sentence and see those two, the first two are little flexible and they're not watertight, but standards are watertight because any standard requires a 80 to 90% of vetting by the members. It may be a long process. Otherwise, it recommendation. Next slide, please. I think this is the last slide.
Okay.
Actionable takeaway for a reliable high-speed interface boards. The best approach is layering all the three. Use guidelines for practical layout execution. Follow industry recommendations for a proven reliability and manufacturability. Ensure formal standard compliance for audit readiness and control assurance. So this is my last slide. But let me add something here. As on last week, 3 new consortiums have been released.
Your voice is very low, Mr. Amba Prasad.
Now it is okay?
No, you have to come closer to the mic. You're
And now
covering
it is
the
okay?
mic. Yeah, now it is
Yeah.
better. Yes. Yeah.
Okay. So I was telling last week, 2 new consortiums have opened up for the data center design and AI design. They are only consortium recommendations. They are not standards, but they are telling that still to get it as a standard takes a lot of time. So this is how it happens. But if you want to rigidly follow standards, they're very tight. They're not flexible. But the recommendations between. You have best of both. You have best of the guidelines and best of the standards. So maybe next session, I will talk about where they are different. Where following one on one will not help, or sometimes you follow standards, but the recommendations will reject it, or recommendations are rejected by guidelines. Maybe that is for another session.
Okay, great. That's a great presentation, I think, by Mr. Ambaprasad, ladies and gentlemen. and definitely there has been little bit imbalance on the voice, which is I think still can be manageable. And so definitely you are welcome to shoot any questions in case if you have. Even you can put it on the comment section of the YouTube after the show as well, so that we can answer it in our next session. So, Mr. Ambaprasad, before we sign off for today's show, you have any particular message for our audience?
I have a very good message. Whenever I
Yes.
interact with people, some people don't like standards because they are not membership giver.
Okay.
And people say standard companies are making money. That's not true. I told you,
Okay.
standard companies which I am interacting with, at least at a personal level, one is a 100-year-old company, one is a 60-year-old, one is 45 years old, one is 30 years old. So if a company has sustained for 100 years, they cannot just sustain for 100 years by selling things. You have to show a auditable track. Standard companies will handhold the product, and if there is any
Yeah.
mistake, in fact, whenever I interact with a standard company, what I like about standards is before a standard is vetted, 80% of the people have to vote for it. There is going to be a lot of dissent in voting. In fact, the
Yeah.
dissent notes, if one can get access to read that, it's a very good learning actually. It is not that they
Absolutely.
do that, but even recommendations, I say they fall somewhere in between, because why some of the recommendations are not getting into standards, because they want to do the product very quickly. In fact, some of the product outlines today, they are larger than the JEDEC trays. JEDEC came with a tray. They say this is the tray size, this is the tape size, this is the tube size. Now some of the components are larger than that. It cannot be a standard. It has to be a recommendation only. So that is what things are. But I feel at least follow recommendations. It is a middle path, middle ground. But following the guidelines alone is a little risky. That's my personal
Okay.
opinion. Again.
Okay, fantastic message. Thank you, Mr. Amba Prasad, for your valuable today's session, and your expertise definitely will help out there. Lot of design people, lot of people in the processes as well as in the manufacturing. With that said, I would like to thank you all the people who watched this show today, and please do subscribe to the channel, because the more the subscribers, more it's a merrier. More the merrier that we say. More the subscribers, more the viewership. Our guests are happy, so that we can bring in more and more weekly topics. All the topics are different. They are not same topics. We don't repeat the same topics. They are different topics and presented in also in a different way. Sometimes I let the guests to present themselves, because they ask me to present their slides so that they can discuss it in a very detailed way. But you are more than welcome to put questions in the middle of the session and also at the later of the session. With that said, thank you very much once again, and wherever and whichever part of the world you're watching the show, please be safe and have a wonderful weekend. Thank you once again, Mr. Amba Prasad. We'll see you next time at the same platform. Thank you very much.
Yeah, for all the members, watchers who watch in a YouTube later on, very happy April 1st. That's your day. Enjoy it.
Thank you very much.